My girlfriend and I just worked for the past 4 days and created a project that won against 100 other teenagers in the coolest hardware hackathon in Texas. But first, how did we get there? Well, that's a great question, future me. A couple weeks ago, the charity known as Hack Club invited to fly both my girlfriend and I to a 4-day in-person hackathon in Austin. So of course, we said yes. Now, with the event just a day away, I needed to pack some of my own electronics, including my secret weapon, which I'll show you a bit later. Anyway, now that I finished packing, it's time for the... After getting to the venue, it was time for day one. We started off with some introductions and finding out where everyone was from. Then they gave us the theme for the event.
So everybody, the day is finally here. Welcome to Stasis! What you been waiting for? The theme! So, the theme for this hackathon for Stasis, the special ingredient you need to have in your project, is one item from the Stasis stash. We have this massive box full of really wacky stuff, like an old alarm clock, an NES controller, and foot pedals, and you have to take one of these items.
Essentially, we would need to integrate one of their special shop items into our project for it to count. Alright then, so Logan, what awesome thing did you get from the shop for your project? I got a fan. It's got some lights, I guess. Anyway. We have time, so we can figure out what to do with that a bit later. We have some good news though. The event theme totally works with the idea I've been cooking up. Alright, so remember that secret weapon I was talking about while packing? Well, those are actually a bunch of ESP32s. If you've been watching my GitHub, you would find that a bunch of my new projects have included one. And since I have so many of them, I could do something really cool. I'm gonna make my own localization, or figuring out where things are, and it's going to be something kind of similar to GPS but on a much smaller scale. Now, tech demos are super cool, but if I wanted to win this hackathon, I would need some user engagement as well, so that each person who tried the project would have something more than the usual to remember. This gave me the idea of having players casting spells at each other, since what would be cooler than being able to cast a fireball at your opponent in real life? So, with our idea in place, we set out on the first challenge. Anyway, while those two figure that out, let's take a look at how the system is actually supposed to work. The main idea starts with these fixed ESP32s around the room. I'm going to call these field nodes. Each one of these nodes would sit in a known position, so one node might be here, node 2 might be over here, and so on. These field nodes would constantly send out little ESP now messages. The spellbooks would listen for those packets, and when they heard one, they could read the signal strength. The basic assumption is that the further you get away from a radio, the signal will get weaker. In a perfect open space, that follows the inverse square law. So, if you double the distance, the signal power drops by a bunch. In the real world, especially inside a building with people, tables, wires, and metal stuff everywhere, it is nowhere near perfect, but it might be able to give us a rough distance estimate. Well, this is the cool part. If one node says the spellbook is about 2 meters away, that does not mean we know exactly where the spellbook is yet. But it does mean that the spellbook is somewhere on a 2-meter radius around that node. So, with one node, all we really know is a circle. If we add a second node, we get a second circle. Now, that spellbook is probably somewhere where those two circles overlap. And if we add a third or fourth node, the theory is that those circles narrow down into one likely position. This is basically the same idea that actual GPS uses, except GPS is using satellites and is more based on timing, with a lot better math. So we are using ESP32s on tables and signal strength, so it gets a lot rougher. My actual implementation was a bit more like a spring system to try and help with the rough signals. Instead of perfectly finding where all the circles intersect, my computer starts with a rough guess for the spellbook position, then each node acts kind of like a constraint. So if the guess is too close to a node compared to the distance estimate, it gets pushed away, and if it's too far, it gets pulled back in. So the server does that over and over again with the most recent readings until the position settles somewhere that kind of makes sense for all the nodes. It's not exact, but it should work a lot better for all of these messy data signals. But all of that only tells us where a player is. For a spell duel, we also need to know which way they're facing and what spell they're trying to cast. So my plan was to put an MPU 6050 inside each spellbook, and it's a little motion sensor with a gyroscope and accelerometer. The gyro can give us an approximate rotation, which means we can estimate which direction the player is aiming. Then the accelerometer and gyro together can be used to detect motion patterns, so if the player flicks a spellbook down or forward, that could become a fireball. If they do a different motion, that can become a shield. The first thing that we needed to prove was way simpler. Then we used signal strength to get distance between ESP32s at all. So let's go back to day one.
That should be around
2.8.
And the results were looking usable, I guess. Not great, not clean, but they should be usable. The numbers would move around quite a bit, which I was expecting. I think I can just put a filter over that. And they were at least changing when the boards moved farther or closer together. Good enough to keep going. So the next step is to add more nodes. We started placing ESP32s around the arena, like anchor points, and then testing if the spellbook could hear all of them. The idea was that once we had multiple signal readings coming in, the server could start estimating position instead of just one distance. By the end of the first night, we had proven that basic tracking idea might actually work. We had ESP32s talking to each other, and we had rough distance data. Day 2 was when I tried to turn the project from a table full of ESP32s into something a person could actually hold, which, as it turns out, made everything worse for a while. The first thing I worked on was building the first actual spellbook. It had pretty much everything I thought we would need: an ESP32 dev board, a bunch of individual LEDs, an OLED screen, an MPU, a buck converter, and a spot for the 9-volt battery. Which, looking back, may have been part of the problem. So, all of this soldering footage is just Jisoo and I trying to turn the idea into a real object, because at that point, the project was still mostly a bunch of boards on a table. Honestly, I'm feeling pretty good about it. It had lights, a screen, motion sensing, its own power. It looked a lot more like a finished hackathon project than a breadboard sitting on a table. And around this point, we also had to do our first project demos. Pretty simple, we just had to go up and explain what we were trying to build.
Creating a system where you can cast spells and take out your other player's opponent.
You can move around in the real world across this whole floor in the venue, and you'll be able to shoot in different areas to hit.
And people got it, which was good because the actual implementation was far from done. Unfortunately, the perf board we had been working on the entire day did not work. The tracking got really bad once everything was on the big perf board. I still don't fully know why, but I figure it's because of all of the extra wires. Well, when your whole location system depends on tiny changes in radio signal strength, putting a bunch of extra wires, modules, LEDs, and power stuff around the radio is probably not the most peaceful environment for it. So, somehow, the version that looked way more finished also worked way worse. At this point, getting the project working is going to matter a lot more than making the actual spellbook look clean. So, we did the very sad hackathon thing where you take apart the cool looking version and go back to the ugly version that actually works. The next version was way simpler. No OLED, no 9-volt battery, no big perf board, just the ESP32, the MPU 6050, and whatever wiring was needed to make it work. It was not as pretty, but it had fewer ways to betray me, so at this point that was kind of the goal. And it did work better. This is the part where the project turned into a bunch of tuning, changing values, and trying again, and again, and again. Sometimes it felt like it didn't change anything. Eventually we got something that worked. Jisoo and I kept moving things around, uploading code, checking a dashboard, and doing it again. The tracking was still pretty rough here, but it was stable enough that we could keep going. So the next thing was the actual spell casting. Each player would have 5 health. If you cast a fireball and it hit the other player, they would lose health. If they had a shield up, it would block the hit. So the spellbooks needed to do 2 things at once: figure out where they were, and figure out what motion the player was making. The gestures we ended up using were pretty simple. A downward motion would cast fireball, and pulling the spellbook back up towards yourself would cast shield. At some point, we got a rough version working where the computer could show a fireball and a shield being cast. The game was not really an epic wizard duel. We gotta fix that. Alright, it's day 3. The project technically exists, but it was still mostly a dot moving around on a laptop. And unfortunately, dots moving around on laptops are not usually how you win the hearts of people. So we needed something that made the spell feel real. And this is where the fan comes back. Remember the fan with lights that I got from the shop? Yeah, well, somehow that became one of the most important points of the entire project. We decided to turn it into a target. So the idea was that if a player cast a fireball at the target, then we could use the fan's motor to kind of show some reaction. This meant that instead of the game only changing on the screen, we could also have something in the room react, which would make it feel a lot better. So to make things more fun, I also included Meghna in the project. Meghna was one of the organizers at the event, and for reasons that made sense at the time, we put her face on the target. Actually, I still kind of think this makes sense. The face was drawn with the blot machine, then glued onto the fan blades.
Okay, now I just need to get this into there.
Did you do something? Did you to get them to follow you?
It's like, it doesn't even look like me. Like,
You guys have
No, that's like 1-to-1.
You guys have an M5.
nobody's gonna be able to find it as me. It's like, it doesn't even look like me.
No, it's gonna be spinning so fast anyway, no one's gonna know.
Wait, what? What are you doing with it?
I'm gonna attach it to the fan. This is gonna be on the fan blades and just spin. Whenever you cast a spell on it, it's gonna spin.
So when you hit the target, Meghna spins, the lights flash, and Meghna gets to react to seeing herself turned into a game mechanic.
Okay, fire.
Right now, I just have it set up with 1, so it has no idea where it is, but it does allow me to shoot at it. So if I do this to cast a spell,
That's so fire! Oh my god! Holy crap! Dude, that's amazing! Holy crap! Dude, this is gonna be so good.
it works so
Oh
well.
my god, that's so good!
This ended up being one of the best parts of the project because it was the most obvious interaction. The tracking was the most complicated part, but the fan could be immediately understood by everyone. If I tell someone that the spellbook is using signal strength from multiple ESP32s to estimate a player's position, that is cool, but it takes a second to understand. If I wave a spellbook and Meghna starts spinning across the room, that takes 0 seconds to understand, which is a lot more helpful in a hackathon type environment. So the target was basically doing a lot of this work for us. The laptop could show what happened, but the target made it feel like something happened. Audio was the next big layer that would help us here. The idea was that each phone would connect to a local page from the laptop, subscribe to the spellbook they were using, and play that player's sounds. So instead of every sound coming from one laptop speaker, the room would have a bit more of a direction to it. That was the plan, and it occasionally worked. But the hotspot on the laptop was not reliable enough in the venue, and sometimes the audio would lag by like 1 to 5 seconds. Not good. Especially when the entire point is that the spell feels instant. So, for the final voting demo, we just turned this off and had all of the audio coming from the laptop. Bit unfortunate, but have to make sacrifices somewhere, right? Making the sounds was still very much worth it though. I got people around the venue to give me their best, or threw some filters on them and used those as the spell voices. It was partly for the meme, but it also made the spells feel a lot less boring, right? At this point, the project was finally more than a moving dot on a laptop. So of course, once the small version sort of worked, my next thought was, what if we made it bigger?
Alright, so I just got this device list put together for each of the locations. So for example, we've got a couple of them that'll be sitting up here, just along this wall. We've got a spot over there, on top of that speaker there, and then on top of that box. And so all together, we've got a nice little map. Should work pretty well. Let's see.
This is where the tracking started fighting back at me. The new nodes I added were too far away. The estimates would start getting pushed way off, sometimes basically into a wall, because the distance readings past 1 to 3 meters were just not very useful. Instead of helping, the extra nodes would sometimes pull the estimate into a wall, which was probably not where the wizard was standing. I first tried fixing this by moving one of the nodes closer to see if I could save the full field setup, but it still didn't really help. So for the final version, we simplified the field again. 4 nodes in a square. It was a smaller area and a cleaner setup. Unfortunately, everyone judging our project would be in the real world, so we would just have to survive with the smaller setup. So, by this point, our demo has some quirks, but it's working well enough that I think players will understand it. Late that night, the project finally looked like the thing we had been describing since day one. It was still held together by a lot of tuning and hope, but it had the important part. Someone could cast a spell and something obvious would happen.
Wow, it got closer. And as I move this way, we've moved further that way. Now, we also have rotation. And so what I can do with that is cast some spells. So I'm just gonna go ahead and reset the rotation since I wasn't able to do that. And now we're good to go. So our other main form of interaction is a trapped soul. That's right, I trapped Meghna's soul inside our project. So I'm just going to cast. I can cast a fireball right up at Meghna. So they light up and spin around a bit. So let's do that again. It works pretty well. Especially considering all of this is done basically with ESP32s. You can also hit the other player. So if I do this, you'll see it takes away their health, and so you can do stuff like PvP. Additionally, if you want to block that, you can go back and you can cast a shield. So yeah, there we go. PvP and nice player interaction.
Alright, it's day 4, which means it's finally time for demos. Would I be able to make this whole system work while everyone is watching? At this point, the tracking's still approximate, the phone audio is gone, the spellbooks were way less polished than the perf board version they were originally supposed to be. If you played for long enough, you could also definitely tell there was some weird stuff. So, would this version of the project be enough to make it past the judge's decision?
Together, we made a GPS tracking system where you can use these spell books to cast spells in your environment. So here you can see the representation of where it sees my spell book right here. And yeah, you can kind of hear it casting spells. So if I move it closer to each one of these areas, you can see it moving around. Additionally, we trapped Meghna's soul inside of the game. So I'm gonna try and hit it, and we're gonna see what happens. There we go. Okay, so we can also do PvP. So Jisoo's gonna plug in hers. And so I am Soul and she is Luna, and now we can do PvP. So obviously we can cast shields, and we can also cast fireballs! So now you can kind of have magic fights with your friends in real life.
There were a lot of other really cool projects there too, so I had no idea if this was going to actually win. After everyone demoed, all of my peers voted, so all of the people at the event would get to vote on projects. But then, they started announcing the top 3.
Drum roll, please.
Number 3.
Stasis! Second place, drum roll, please. Drum roll, please.
Wait.
And somehow, after 4 days of radio noise, soldering, motion sensors, relays, broken plans, and the spinning organizer target, we won. That was awesome. And with that, it was time to go home. The project was definitely not perfect. The tracking was really approximate, the phone audio wasn't able to make it, and the spellbooks were way less polished than the first prototype it was supposed to be. But the demo made sense. You just picked up a spellbook, made a motion, and things happened. That was awesome. We made magic in real life, and we were able to win the hackathon. The full project is open source on GitHub, just like all my other projects. So if you want to take a look at the code or any of the pretty pictures I made for the event, it's all there. And that's how Jisoo and I made a real life wizard duel in 4 days.